Welcome to another video lecture. In this video lecture, we will discuss if all the elements of a row in a Routh table becomes 0. So here is one example. F of s, the characteristic equation is given to us, s to power 6 plus 2s to power 4, sorry, 2s to power 5 plus 8s to power 4 plus 12s cubed plus 20s squared plus 16s plus 16. So let us first draw the Routh table for this particular characteristic equation. Now we will start with the highest power of s, which is s to power 6. Then we will write s to power 5, s to power 4, s to power 3, s to power 2, s to power 1, and s to power 0. So the coefficient of this row s to power 6, we will start with the highest power, which is s to power 6. The coefficient is 1. Then we will take the alternate coefficient, which is 8. Next alternate coefficient is 20, and the next alternate coefficient is 16. The coefficient of s to power 5 will be the coefficient of s to power 5. First element will be 2. The next coefficient is the alternate of this coefficient, which is 12. Next coefficient is the alternate coefficient, which is 16. Next coefficient is not there, so we'll assume it to be 0. Now to calculate the coefficient of this row s to power 4, we will multiply this 2 with this 8 and minus 12 into 1 divide by 2. So let me write this calculation here. 8 into 2 minus 12 into 1 divide by 2. So this will comes out to be 16 minus 12 divide by 2. So this will comes out to be 2. This next coefficient here, we will multiply this 2 with this 20 minus 16 into 1. 16 into 1 divide by 2. Let me write it here. 20 multiplied by 2 minus 16 multiplied by 1 divide by 2. So this will comes out to be 40 minus 16 divided by 2. So this will comes out to be 12. And similarly, we can calculate this coefficient, which is I'm writing directly here, 16 into 2 minus 1 into 0 divided by 2. So this will comes out to be 16. So you can see that the coefficient of s to power 5 and s to power 4 are same, 2, 12, 16 here and 2, 12, 16. So when you will calculate the coefficient of s to power 3, since we multiply these two and divide by 2, so all the coefficient of s to power 3 will become 0. Let me give calculation of this first element. This will comes out to be this 2 multiplied by 12 minus 2 multiplied by 12 divided by 2. So since both the numerator terms are same, so this will become 0. So this will be 2 into 12 minus 2 into 12 divided by 2. So this will become 0. So this will be 0. Again, this will be the next term here. This will be 2 into 16 minus 16 into 2 divided by 2. So this will be 16 into 2 minus 16 into 2 divided by 2. So this will also 0. So you will see that all these coefficients of s to power 3 will be 0. So this is the calculation here. Now, so in this case, when all the elements of this s to power 3 row becomes 0, it is not possible to calculate the remaining coefficients of this Routh table, and hence we cannot predict whether the system is stable or not. So in these type of problems, how to proceed further? So what we will do in this case, we will first form a polynomial by using the coefficient of a row which is just above the row 0. So what is mean by this? Let us assume that this is the Routh table. S to power 6 is the highest power, s to power 5, s to power 4, and these are the coefficient x, y, z, p, q, r, and this coefficients, s to power 4 coefficients becomes 0. Then what we will do, this is the row just above the row 0, and we will form a polynomial from this equation. And how to form the polynomial? This coefficient p will be multiplied by the highest power, which is s to power 5. So this p will be multiplied by s to power 5 plus, since we take alternate coefficients in a Routh table, so the next coefficient q will be multiplied by the s to power 3, which is the next alternate power of s in the Routh table, and this r will be multiplied by the next coefficient next s to power, which is s to power 1. So this is how we will form the auxiliary polynomial. This polynomial is known as the auxiliary polynomial AS. So we will first form the auxiliary polynomial by considering the coefficients just above the row 0. Now in this next step, we will take the derivative of this auxiliary polynomial. So the derivative of this auxiliary polynomial is 5p s to power 4 plus 3q s square plus r, and then we will put these coefficients 5p plus 5p 3q and the coefficient of r s to power 0. The coefficient is r, so we will put these coefficient instead of 0 in the next row of the Routh table, and then we will complete the Routh table by considering these coefficients and then observe the sign change. Let me do this for this particular example here. So in case of this example, the s to power 3 coefficients become 0. So if you can remember that these coefficients become 0. So now we will form the auxiliary polynomial for this question. So the auxiliary polynomial comes out to be 2 will be multiplied by the highest power, which is s to power 4, plus this 12 will be multiplied by the next alternate s to power. So this will be s square. So this 12, let me erase this again. So this will be 12 s to power 2 plus next is 16. 16 will be multiplied by s to power 0, which is 1. So this is the auxiliary polynomial for this question. Now we will differentiate this auxiliary polynomial with respect to s. So this will be 8s cube plus 24s plus 0. Now these are the coefficients 8, 24 and 0 of this s to power 3. So we will replace these zeros with these coefficient 8, 24 and 0. So let me erase this once again, these 0 here, and put these coefficients 8, 24, 0 instead of 0, 0, 0 in this row s to power 3. Now I will calculate the coefficient of s to power 2, s to power 1 and s to power 0 by using the same formula, by using the same technique which I used in the previous example of Routh table. So the first coefficient of s to power 2 will be 8 into 12 minus 24 into 2 divided by 8. Let me write it here. So this will be 12 into 8 minus 24 into 2 divided by 8. So this will comes out to be, I think this will comes out to be 6. And the next coefficient here, so this will be 6. The next coefficient will be 8 into 16 minus 2 into 0 divided by 8. So this will be 16 into 8 minus 2 into 0 divided by 8. So this will comes out to be 16, and the remaining coefficient will be 0. And let me write all the coefficients of this Routh table here. So these are the coefficients of this Routh table. Now after completing this Routh table, we will observe the sign change of the first column of this Routh table. If there is no sign change in this first column, we will again have to check one more condition. But if there is any sign change in the first column of this Routh table, then we can say that the system is unstable. So in this case, we will check one more condition whether the system is to predict whether the system is stable or not. Now we already discussed that if there is a sign change in the first column of this Routh table, of this first column, if there is any sign change, then we will say the system is unstable. But if there is no sign change, then we will check the roots of the auxiliary equation. Now you remember that the auxiliary equation we form by this row s to power 4. Let me write it again here. So as is equals to 2 s to power 4 plus 12 s square plus 16. So we will find the root of this auxiliary equation. Let me again rearrange this equation s to power 4 plus 8 s square plus, sorry, so let me again this 6, this will be 6 plus 8 equals to 0. So this is the auxiliary equation. So to find out the roots of this auxiliary equation, we'll assume that s square is equals to x. So this equation now becomes x square plus 6x plus 8. So this becomes a quadratic equation. So you can easily find the roots of this quadratic equation, which comes out to be minus 4 and minus 2. So hence s square is minus 4. So we will have two roots here. So s will be plus minus 2j, and when s square is minus 2, so in case s will be plus minus under root 2j. So these two roots, if I can locate these roots on the pole 0 plot, so this is the real axis, this is imaginary axis. So you can plot these values as values on these pole 0 plot. So plus minus root 2j will be somewhere like this. So this suppose this is under root 2j, this is s2 minus under root 2j, and let us suppose this is s3 2j, and this is s4, which is minus 2j. So all the roots of the auxiliary equation lie on the imaginary axis. Hence we can say the system is marginal stable. So if this is the seventh condition, if the roots lie on the right side of the S plane, the system is unstable. Roots lie on the left side, system is stable. And if roots of the auxiliary equation lie on the imaginary axis, then we will say system is marginally stable. Hence finally we can predict, or we can say that this system is marginal stable, marginally stable. So this is how we can solve these cases of Routh-Hurwitz criteria. Thank you.